Hi guys, and this is our video on angles of polygons. So first, let's just start off by saying what is a polygon. Okay, so let's do, these are polygons. These are not polygons. All right, so our polygons can look a lot of different ways. Let's see. Okay, and a not a polygon would be something like this. Oh, let me do another example of a polygon. Not a polygon would be that. This. Anything that looks like that. So if you notice, a polygon is something that has only straight lines. Okay, so if you notice, all of these are straight. Okay. It has to be a closed figure, which means if I just have three lines like that and it's not closed, it is not a polygon. Okay? It can either be concave or convex. This is convex, and that basically means that all of your interior angles are less than 180. And this is concave. And the easiest way to think about it is if it's concave, it's been caved in on one side. So it's like it's got a dent in it. Okay? And then if you're talking about not polygons, a circle is not a polygon because it has to be a straight line, no curves. Just like this one right here. You've got straight lines and then that curve makes it not a polygon. This one's not a polygon because it's intersecting. Okay? And this one's not a polygon because the ends are not, excuse me, the ends are not connected. All right. So again, real quick, convex, which is really what we're going to be looking at, just looks like a regular old shape. Okay, and concave, remember I said it's going to be like it's caved in. So that would be something like that. Okay, so something that's caved in. To me, that's just the easiest way to think about it. And for the most part, we're only going to be dealing with convex polygons as far as we're doing. All right, now, on your notes, you should have listed all of the names of the polygons. All right, now what I would say, just to help you, is I would memorize 3 through 12. Okay, so if I say dodecahedron, you need to know what that means. Okay, it's just going to help you because if they say dodecahedron, they're not going to tell you how many sides that is. All right, so now let's talk about interior angles. All right, so if I have a triangle, okay, can I draw a diagonal on that? I can, right? And I know that a triangle is equal to 180 degrees, right? You guys all know that. All right, if I have a quadrilateral, how many diagonals can I draw? I can draw my diagonal there, or I could draw it connecting those two vertices. All right, so how many triangles do I have? I have 1, 2. So if one triangle is 180, then 2 triangles is going to be 360. Okay? All right, so let's do a pentagon. All right, so how many diagonals can I draw? You pick any vertex you want. So let's start at this vertex. And you connect it to every available vertex that is across from it. So you connect it here, and you connect it there. Okay, I cannot connect this one to that one because it's the same line. I can't connect that one to that one because it's the same line. And I can't connect these two because now it crosses. All right, so how many triangles do we have? We have 1, 2, 3. So that means you have 3 times 180 equals 540. Now what I would do is I would memorize how many degrees are in each polygon. It's just going to help you, especially the first, I would say 6. It just makes it a lot easier. So let's talk about a formula. All right. So the triangle has 3 sides. All right. The quadrilateral has 4 sides and 2 triangles. Right? The pentagon has 5 sides and 3 triangles. That means that for any polygon, you take the number of sides, so n is going to be number of sides, you subtract 2 and multiply that times 180. And this is going to give you your sum of interior angles. Okay, whenever you're connecting the diagonals, I want you to look at something. You're always leaving out 2 vertices, so we're leaving out this one and that one. That's why you subtract 2. We're leaving out this one and this one. That's why you subtract 2. This one, since it's already a triangle, it's okay. All right, so, excuse me. So now we're going to talk about if you have a regular polygon. All right, so let's just say, let's do a hexagon. Okay, we're going to pretend that's that regular. All right, and I want to know how much each, so what is the measurement of each interior angle? Okay, first of all, if it's a regular, that means that all of these angles are the same. All right, so the first thing you want to do is you want to use our formula, so it's n minus 2 multiplied by 180. Our sides is 6 minus 2 times 180, so that gives us 4 times 180, which gives us 720 degrees total. So that means if I were to take this angle, this angle, this one, this one, this one, and this one, and I added it together, I would get 720. Now because all of the angles are the same, you're going to take that 720 and divide it by the amount of sides. So since this has 6 sides, because there's 6 angles, you're going to divide by 6, and that means that every angle, so the interior angle, is equal to 120. All right, so the formula for that is our first formula, right? Because you find the total amount of the angles, and then you divide it by however many sides it has. So this is interior angle. Okay? All right. Now the second part is talking about exterior angles. So if you have a triangle, your exterior angles are going to be when it extends like this. Sorry, I did this one wrong. No, it doesn't matter. Okay, so basically the exterior angle is the angle on the outside. So this angle, give me a second guys, sorry. Okay, so this angle right here, and this angle here are exterior angles because they are on the outside. Okay, the sum of the exterior angles of a polygon, okay, are always 360 degrees. Okay, so it doesn't matter how big. I want you guys to think about something. Okay, so we start off with a triangle. And I showed some of you guys this in class. So that's three-sided. Then we get four-sided, five-sided. Okay, so that's 6, 7. It's not going to be perfect. Okay, so 8. Okay, even in my bad drawings, it starts to look like a circle. And we know that a circle is 360 degrees. So that means that the distance around here is 360. Okay, so the sum of all of your exterior angles is always going to be 360. So just think about the more sides it has, the closer it gets to being zero. I'm sorry, to being a circle. That being said, if I give you a polygon and I say, what is the measure of each exterior angle? So if I've got, let's just do a hexagon again. Okay, so I've got a hexagon, and I know that each exterior angle added up together is 360. If I want to know how much each one is, all I'm going to do is I'm going to take 360 and I'm going to divide it by the number of sides, and that's going to tell me what one exterior angle is. Okay, now this only works if you're doing regular polygons. Because if they're not regular, then they're not going to be divided equally. Okay, well I hope this made sense. It's not real difficult, it's just kind of understanding, knowing what the formula is. Let me know if you have any questions, and I will see you all tomorrow.